Welcome to September edition of Innovation Insights. My name is Dale Brosius. I'm the Chief Commercialization Officer for IACMI, and we've got another great slate for you today. Hope everybody's enjoying their fall. The weather is good where you are. So without further ado, let me just go through a couple of slides as an introduction. Just reminding you of IACMI, formed around the theme of convene, connect, and catalyze. We want to bring people to into places, connect them, and then make things happen. So, facilities for on-site innovation, networking projects, working groups, interns, workforce development, and so forth. Just a couple of things. We will be present at CAMX, and you'll hear a lot more about that today from Cindy Squires, as to why you need to be there as well. We know we need to be there, and we hope to catch up with many of you there. And then at the end of November in Salt Lake City for the Carbon Fiber Conference from Composites World. Just a reminder, this webinar is being recorded. It is, and it will be available on our website, as all of our previous Innovation Insights webinars are available on our website. So if you've missed something in the past, or you see something today and you want to go back and relive it, it'll be up in a few days. As a recording, or if you know of a colleague or friend that you think should be interested in something that was presented today. So our slate today includes three great speakers. We're going to start with Jeff Valentage from he's the America's Automotive Director for Materia Incorporated, which is an ExxonMobil solutions company. That'll be followed by Todd Altman. Todd is a Senior Director for Automotive for TPI Composites, and I know many of you think of TPI, you think of wind, but they do have a robust automotive truck and bus business. And Todd's going to talk to us about the latest SuperTruck project, which was very composites intensive. And then finally, going back to CAMX, we have Cindy Squires, who is the CEO and President of the American Composites Manufacturers Association, and I'm sure she'll give us a little insight about ACMA, but also we'll really focus on what's going to happen at CAMX this year and why you should be there. So I will in my slideshow, and we will turn it over to Jeff.
All right, thanks, Dale. Let me see if I can.
I'm just going to go into slideshow mode and we'll be good to go. There you go.
All right.
Take it away, Jeff.
All right. Thanks, everybody, for joining this morning. Again, Jeff Valentage with Materia, which is an ExxonMobil subsidiary. I am the America's Automotive Market Development Manager. Any questions that anybody has about what I've shown today, there's my contact information. I'm the only Jeff Valentage at ExxonMobil Chemical, so it's pretty easy to contact me. So today I'll provide an overview of ExxonMobil's view on kind of the light vehicle transition, kind of what we see with electric vehicles. I'll also give an introduction to who Materia is and Proxima. I'll also provide a high-level overview on material performance, and then discuss some of our development activities in the RTM application and process space. So looking at the light vehicle duty demand, so in 2021, the global fleet was about 1.3 billion vehicles, with roughly 20 million of those vehicles, or 1.6% of the fleet, being plug-in hybrids, battery electric, and fuel cell vehicles. By 2050, these advanced vehicles we see growing to about 42% of the fleet, or roughly 875 million vehicles, and then more than 50% of the new car sales. So I think that's a key distinction between some of the data that you see out there. We always hear about new car sales, but really what counts is the fleet. So we have to look at the overall fleet. And so as we see that transition happening to these alternative vehicles, we'll see that fleet grow of those vehicles as well over time. And really, this is driven by decreased battery costs, policies looking at tailpipe emissions, efficiency, and reduce countries reducing their dependence on imported oil as well. And if we look at the light duty vehicle demand for internal combustion engines, we see that projected to peak around 2025 and then decline to levels seen around the 2000 era by 2050. As we see more and more people convert to electric vehicles. So if you look at the right, today, plastic makes up about 50% of the volume of a new light vehicle, but is still less than 10% of the total vehicle weight. Plastics and composites will continue to play a key role in improving vehicle efficiency, safety, and durability. And we see that regardless of the drivetrain type, as consumers continue to want to see or purchase large trucks and SUVs, those efficiencies play a key role in those vehicles as well, along with the electric vehicles as well. As society transitions to more electrified vehicles, weight is going to be a key critical area to achieving the range, improved reliability, and safety. And for composites, the key enablers are really going to be around improving the productivity. So not only cycle time, but the overall productivity of producing parts, increased supply and security. So increasing the supply of composite raw materials and the suppliers that produce those key end-use parts as well. And then really improving on the sustainability and the life solutions as well. And I think for electric vehicles, everybody kind of knows that it's a kind of a well-known fact. EVs today, they have about a 6 to, and if you look at the Hummer EV, about a 1,500-pound weight problem that really the industry needs to solve. And we believe composites can play a key role in that. So who is Materia? Materia was a company that ExxonMobil purchased late last year. It's headquartered in Pasadena, California, and a manufacturing facility in Huntsville, Texas. It has developed Nobel Prize-winning catalyst technology that really challenges the traditional thermoset material trade-offs, and I'll talk about that in a little bit. With the combined strength of Materia, its technology, and ExxonMobil's scale, global supply, and manufacturing expertise, we aim to bring kind of a step change in scalability and performance to the global composites industry, enabling the composite industry to expand the supply of these very high value, high performance composite end-use products for not only the automotive industry, but for other industries as well. So looking at Proxima, Proxima is a DCPD resin. It's a polyolefin thermoset. It is a tunable two-component system, so it's a resin and catalyst that enables a range of products. So depending on the customer's needs for the end-use performance, we can tweak and tune the product. It's very versatile in the processes that it can be used, RTM, rim, filament winding, and also protrusion. And as you can see, looking at the graph on the left, so our product offers very fast infusion, and I'll show a video showing that here shortly. But the key is we can flow that material through very long distances and through a lot of multiple layers, and we don't have to sacrifice toughness with this material. So that's a key difference between typical composites that are out there today. You can also see we offer a low density, so around 1 density. We typically, with our grades, we also have a lower CO2 footprint. If you would like some more information on that, you can follow up with me and we can discuss that. But typically we're a lot lower CO2 footprint than other resins. And then it's actually, because it's a polyolefin based material, it fits very well with ExxonMobil's advanced recycling capability. So we can take used plastics that would normally end up in the landfills. We can take those, we can recycle them in our advanced recycling process, break those down into the basic molecules, and then produce new value added plastics or composites materials for future use. Now I'm going to show a couple short videos to kind of show you some of the performance of Proxima. So this is looking at infusion. So the DCPD Proxima materials at the top, the epoxy standards at the bottom. You can see how fast Proxima will flow. So this particular plaque, it was 4 minutes. And the epoxy at the bottom, still going. Still going. So very fast infusion times. And then this is a real world application looking at a wind turbine blade that we did with the customer. And then the top is Proxima, and then epoxy is at the bottom. So again, this 31-meter wind turbine blade, we did it in fairly quickly versus the epoxy, 41 minutes versus I think it was 185 minutes for the epoxy blade. So customers looking for significant reduction in overall cost to produce materials. So just in cycle time alone, you can produce those parts much quicker. And then with this turbine blade, because we have a lower density, there was no other changes done to the blade. We were actually able to save the customer 4% weight savings without anything, no other changes to the blade. And then looking at snap cure. So this is just a kind of a quick video to show, this is a lab experiment we have in one of our containment booths, just to show how fast we can cure the material. And this can be dependent on the catalyst and resin system that you are looking at for your specific application. So we can tune this, but this was in 6 seconds. And then this is also a spray application that we did with the customer. So the interesting thing with Proxima is not only can we do thermoset applications for automotive and construction, but we can also produce the material in a spray formulation that can be used for coatings and other things. So this particular application typically takes 2 coats. We can do it in 1 coat, and we can do it in significantly faster time. So this application, we were able to do this for this customer in less than 10 minutes. And it typically took the customer 10 to 14 hours or 12 to 14 hours drying time for this specific application. So again, just showing the versatility and use for this material. All right, turn the video off. So looking at specific toughness for composites, again, remember I said that, Proxima is typically DCPD materials were used in rim applications because typically the catalyst would have bad reactions or wouldn't react properly with the use of any types of reinforcements. We do not have that issue with Proxima. So the catalysts don't have any adverse reactions or slowing reactions with any reinforcements. So you can see here in these testing that we did with customers looking at toughness, the crack resistance significantly significantly higher with the Proxima materials. Typically with our materials, you typically just see a yielding versus the epoxy that is used with this general epoxy. Typically you have a catastrophic type failure. Again, we typically yield. You can see on the bottom left with the impact strength. So if you have automotive applications where you're looking at reducing the damage from an impact area, again, we typically have with this falling dart impact, we can show here, typically have a significantly smaller impact area with our materials versus the epoxy sample that we're using. And then looking at tension fatigue, you can look at other different fatigue testing, but we're able to significantly increase the cycle times to failure with our material versus a standard composite setup. Real quick, looking at chemical resistance. So this is looking at neat Proxima applications for chemical storage applications. You can see that very resistant to caustic type of materials. This customer was looking for this 12-month test at 60 degrees C. We were able to pass all the requirements looking at that application. And then also water resistance. We have significantly lower uptake in water resistance. So that's important to ensure that you maintain physical properties over time and also dimensional stability of the application as well. I will, so Dale, I'll look at the questions at the end and answer those. So I see there's a few questions that are coming up.
Yeah, I'll pose them to you when you finish.
Okay, sounds
Yeah.
good. Again, I'm not going to go through all this data, but the point of putting this data in here is, again, remember I mentioned that Proxima can be used with reinforcements, so whether it's glass, carbon fiber. We're also done a lot of work with natural fibers. We don't have that inherent issue with the traditional DCPD materials, where our catalyst doesn't have any adverse reactions with any of the reinforcements. You can see on the left, this is a glass reinforcement laminate that we did for a customer. And then on the right, a carbon fiber laminate that we produce. And again, we were able to meet or exceed all the specific performance requirements for this particular laminate buildup. And also, like I said, we're also compatible with natural fibers like flex and some of the other fibers that the OEMs are currently looking at today as well. And then lastly, I'm going to talk about our development activities with RIM. So we've been in cooperation with Fraunhofer Institute up in London, Ontario. We've been working on looking to improve the cycle time of RTM with our fast fill cure Proxima grades. The tooling that's being utilized is what we call this Frankenstein part down at the bottom. Which we affectionately call that. You can see the cross section on the right. It's a fairly complex part. The center actually has a nylon foamed insert, and it's center gated. So the material literally has to flow not only through that nylon insert and around, but also has to flow through across all this complex geometry. And the fabrics that we've been currently working with is glass and carbon fiber. And we're looking at doing some flax fiber development in the future. Initial trials show very positive results. We were able to do a cycle time of less than 2 minutes without any optimization and using this prototype tooling. So we look at doing additional work in 2024 on this particular part. And then lastly, just to talk about the grades that we've chosen for this particular development. So the two grades that we have today that we're working with is EXP 1401B and 1937B. These were chosen because of their ultra low viscosity, 40 centipoise or below. And really that's for two reasons, because we want to make sure we get very fast fiber wet out, like I showed you in the video with the infusion of the wind turbine blade. We want to be able to wet out those fibers uniformly across the part, but also minimize fiber disruption. So that's a key area that we're looking at. Again, very low density with these grades, 1.07. And you've seen in the previous videos, we got very fast cure time and also extended pot life. So those two we can control based on the catalyst / resin system that we are putting together for a specific application. So if a customer needs some extended pot life because of the way they produce the parts, we can certainly look at that too. We're generally fiber agnostic. So whatever fiber the customer or layup the customer wants to work with, we work with all the suppliers that are out there. This is just the fabrics that we've chosen for these particular developments in this initial application, but we're open to other fabric producers and or layup designs. And then really the goals that we continue to work on for this in 2024 is continue to work on improving the cycle time. Like I said, maximizing that fiber wet out so we get really good mechanical properties and consistent mechanical properties across the part. And this activities and work will continue in 2024. So just kind of to finish up, because I know we're short on time for each speaker. So light duty fleet continues to grow with 50% electrified by 2025, and we see that consistent, consistently growing over time. You know, there's other predictions out there, but at the end of the day, the consumers are going to drive how this transition goes, and whether it's electric vehicles or the typical traditional gas-powered vehicles, we see a fit with this product in regardless of drivetrain. We also see advanced lightweight plastics and composites continuing to play a key role in these future vehicles. Again, especially with electric vehicles, they have a really big problem with weight, and composites is a great opportunity to take advantage of the performance and the lightweight. And then Proxima polyolefin thermosets, ultra low viscosity, very fast cure, and we can balance that with the performance. Broad processing fit across a lot of the typical processes that are used for these automotive applications, and broad application fit as well. So we're looking at a lot of structural applications, suspension, drivetrain, and including hydrogen tanks as well. And then certainly would happy to be able to discuss with OEMs and other tiers about our CO2 footprint and looking at our potential for advanced recycling with these materials. And last, like I said, stay tuned for our activities in 2024 as we continue this. So happy to open it up to questions, Dale.
Okay, well, we have a lot of questions, and because of the time, and we'll move on to Todd. You can go into the Q&A panel and type your answers into those for everybody to see. There's 5 questions there, and over in the chat, there's 2 questions as well. So if you'll respond in the chat to those questions, and make sure you put on who can see the messages to everyone, so that they can do that. But great talk. I mean, obviously lots of interest, lots of questions, and I know you'll do a good. One of the reasons I put you up first is because I knew you'd probably get some questions, and we can get them answered here within the time of the webinar. So thanks again, Jeff.
Thanks.
Okay. All right, we'll move on to Todd. And Todd, I see you've already pulled up your slides. Just put them in a slideshow and we can go. Todd Altman again from TPI Composites.
Good morning, everyone, and hope everyone had a great weekend. This morning I pulled together a summary of our completed SuperTruck 2 program with Navistar. And so to provide a sense of, I know this is kind of a short, called 15-minute chat. I want to cover a few things. So first thing we'll walk through is just really quick on TPI. We'll discuss the truck market, upcoming kind of changes, challenges that the OEMs are seeing, and how this impacts vehicles and really product development. And then we'll dive into the SuperTruck 2 program and its goals. So what is SuperTruck? And then really walk through scope of the parts, the value of composites, right? Why do you want to do this? And the results of the program, right? How did we do? So if we move to next slide, let's talk about TPI. I assume some of you are not familiar with TPI, so I thought it would be good to just spend just a few minutes here. One is we've been in business for over 50 years. We are a global composite manufacturer with facilities located around the globe, and currently we achieve about just less than $2 billion in annual revenue. And as Dale alluded to before, is we are the largest independent wind blade manufacturer in the world, and we supply to leading turbine manufacturers, so GE, Vestas, and others. But in addition to our wind business, myself and others, we've been working diligently on building an automotive business that leverages our materials and global manufacturing capability. And the really cool thing is, as this has evolved, is now we have production parts on vehicles. Unfortunately, I can't disclose what those are to you guys, but we do have parts on cars today, which is really exciting. And for those involved in the industry, know it takes time and dedication to make that happen. But I think one of the things I just want to comment here about is really one of the items that I think makes us unique is the ability to quickly work with our customers on designing, prototyping, and then really building that product, really anywhere in the globe, right? I mean, that's truly our expertise of being able to do that. So this gives you just a little bit of a very short amount of time, kind of who we are, what we do. At the end of the day, we build composite parts, right? Typically they're large, typically they are complex. It doesn't mean we don't build smaller things, but again, in terms of our expertise, this is what we do. So if we turn to what's going on in the market, right? And I think this is really, really interesting, right, in terms of what's happening, right? And this is, I'll spin it for the truck side, but it's really across the board. Of you have these drivers, right? These things that are happening, right? Whether it's battery electric, hydrogen fuel cell, right? ZEVs are going to happen, right? You have mobility, right? Autonomy. You have new players, right? We can make a whole list of who those new players are. And you have the globe, right? Global governments, right? Basically saying all these really strict emissions requirements and mandates are happening, right? There's no debate about this. And I think the interesting part is then looking at, okay, what does that require from a solution standpoint? And Jeff alluded to this in his presentation of these new solutions have a mass problem, right? And so how do we come up with solutions that are lighter weight? I think the other point is the development of the vehicles, right? People are trying to compress that, right? In terms of how do we go faster? And then the interesting piece here is how the market gets kind of splintered, because now you have, not only do you have an ICE offering, but you have a, in the truck market, a BEV offering, and now you may have a hydrogen fuel cell offering. So now you've got to be more flexible and adaptable, right? And no one has the crystal ball of what this all looks like, right? So really challenging in terms of what's happening. And so I think if you look at the results of what does this really mean, right? To me, it's volumes are going to be essentially, not the overall market's going to be lower, but you're going to have lower production runs. You're going to have quicker changes based on technology, right? Batteries today are going to be very different from batteries in 5 years, right? So you have all these things that are happening. What does this really mean is you've got an opportunity for composites because of lower investment costs, quicker time to market, right? And other advantages we can bring. I think the other piece here that's really interesting is around purpose-built products, right? Everyone who develops vehicles, when they try to make changes, typically legacy manufacturers, the first thing they do is they just try to bolt this new powertrain onto the vehicle. And we've seen in automotive that this just does not work, right? You can go down the list of products where they've taken a legacy product and trying to do it. So all of this just kind of sets the stage of what's happening in the market. And I think it provides an opportunity for composites. So if we look at the trucking market, I thought this was interesting just because, again, I think a lot of us don't spend a ton of time in the trucking market looking at it, is how much trucks move really in terms of the economy and freight, what they mean in terms of, right? I mean, 3/4 of freight is shipped via truck, right? And then you look at how many trucks are on the road, and then you look at the heavy duty truck number. It's actually doesn't, it's 4 million units. It's not a ton of trucks. But the interesting point when we look at pollution and emissions, actually it's a big piece, right? So there's an opportunity here to make a difference. And I think this is the point of really the SuperTruck program is how do we make a difference, right? And how our government's pushing the trucking manufacturers to help develop solutions that are much more energy efficient, right? And being able to do that. So the one thing I want to do before I jump into the SuperTruck part of the presentation is just want to thank Dean Opperman. Dean's been our key contact. He's the chief engineer and manager with Navistar on the SuperTruck programs. And really here, to me, this is about collaboration. And as you're going to see in the results that we've been able to achieve, right, when organizations work together and truly try to collaborate, right, you get these synergies and you're able to, exceed the expectations in terms of the results. So really good partner here. We've got an excellent working relationship, and just wanted to thank Dean for his support over the last several years on the program. So let's talk about SuperTruck, because a lot of people, I think, are not familiar with what a SuperTruck program is, right? And basically it's a public-private cost-shared program that promotes the development of technologies to improve freight efficiency. Many of the leading truck OEMs participate in this program, and there are really three targets here that I've listed. And the first one here is all around freight efficiency. So greater than 100% improvement of freight efficiency. And basically the difference between freight efficiency and miles per gallon is freight efficiency takes into account essentially mass and how much cargo you're moving. So in the trucking world, this is I'll say it's a better indication of efficiency than miles per gallon. I think for most of us, including me, when we think about this, miles per gallon is just easier to comprehend, right? Because we all have cars, we all drive, right? It's easier to think about. The second one here is around the second goal is around brake thermal efficiency, right? And I'm not going to go into detail. This is really not one we had a part in the program, but again, it's the one of the key deliverables from a SuperTruck program. And the last thing here is development of cost-effective efficiency technologies. And I think this is really, really important because in previous programs, people were using technologies and products that didn't have a path to production, right? Using really expensive materials, using things that, right, cost is critical on these type of vehicles, and being able to use, to me, materials that have a viable path to production. Basically, the DOE stated this needs to be a part of the program of, what we do and how we implement it. And I think, here, I'll just talk a little bit about it. I'll go into a little more detail, right? Is we're using predominantly glass as the reinforcement, right? We could use carbon, but the reality is if you're using carbon at 10 to 15 times the cost of steel, it's really not viable, right? In most cases. Now, if we can combine the materials, right, and that's what we've done, we can become very cost effective. And I think that's the goal and what we're trying to do. So again, here, I think just understanding what the goals are, what SuperTruck is, I think helps the basis of what we were trying to do and how we were working with Navistar. So let's talk about the scope, right? What were the parts that we worked with on Navistar? And if you go from left to right on the screen here, you'll see the cab, right? Sleeper cab. And what's different here is in a typical truck today that's on the highway, you have a metallic substructure, and then you have composite panels that cover that substructure. So non-structural panels that are covering the truck cab. What we've designed here with Navistar is actually an all composite cab. So there is no metallic substructure, and a number of advantages from mass to component reduction. There's a whole host of things that we'll get into here in a slide. Aero, as you can see, very, very comprehensive Aero package, right? Where you see not only on the tractor, but also on below the trailer, the amount of Aero that was actually designed and developed for this program. And then on the far right, you have the trailer box. And this is where a lot of innovation and development was spent, was developing an Aero trailer, right? And we designed with Navistar and built that entire box that you see on the screen here. So about I'm going to call it a little over 45 total components we did on the truck. And if you look at the whole truck, it's a large percentage of the entire, I'll call it the truck structure of where we were involved. So that was our involvement with Navistar. So if we talk about what was the value of why you would want to use composites, and try to help the program, right? I think some of these are pretty obvious, but I think some of them are not as obvious. And I'll just kind of run through these and add a few comments here. But mass reduction is obviously, to me, an obvious one, where if we can save mass, that can equal higher freight efficiency. As I mentioned before, replacing metallic structure, right? So we've got component reduction, we've got simplification of assembly, right? These are all good things. Being able to form complex shape, right? Composites give us that, you're going to hear this reoccurring theme about Aero, right? Aero was really, really key to this program and what we could do with Aero with composites versus traditional metallics. And again, here, if you just think about on the top of the trailer, there's actually a whole series of solar panels. And again, here with the design is we were able to basically make the trailer box have an indentation where we could drop in these solar panels. So there wasn't any, so now you're getting the benefit of solar, but with not any Aero penalty of being able to place these panels on it, right? As I mentioned before, cost efficiency at lower production volumes, right? To me, as the truck market gets splintered, right, being able to develop products that, the tooling, right, we'll use SMC as a technology, or metallic stamping. When you get into metallic tools, it's not effective at low volumes, right? So this becomes a big challenge. And then obviously the advantage of composites, if we've got a fiberglass dominant design, right, as an insulator, right, now my being able to heat and cool that cab is much easier and more efficient, right? So I'm not using energy that is essentially, I'll call it wasted energy. One that I think is really interesting here is that on traditional trailers, right, those surfaces aren't necessarily flat, and they may have composite panels, but typically they've got edges, they've got rivets. All of those things really affect aero performance. And what you'll see on the cargo box we developed is you've got, soft, rounded edges, soft, right? That the sides are completely flat, so you get much better aero performance, which again will lead to better miles per gallon, better fuel efficiency, right? Obviously corrosion, and then the point I made before about production viability, right? Of being able to design solutions that can go to production today for all intents and purposes, some of the solutions and the technologies we're using. So when you look at this list, to me, it's comprehensive in terms of, you're not getting one thing, you're getting a number of things. So let's dive into the actual build, and I'll show you guys some pictures of actually what we did. So on the left-hand side of the screen is the sleeper cab, and then on the right-hand side of the screen, you'll see the Aero. On the left, you'll see, essentially we built it in a number of parts that were, then essentially bonded together. Again, as I mentioned, you can see actually the carbon where we placed it, right? And again, if you look at this, it's a very small amount of carbon, particularly in truck cabs. Usually, a key place that we're going to apply carbon is right here on these A-pillars. Because why? Because we want to reduce from a safety and a visibility standpoint. We want those A-pillars, that cross section, to be as small as possible. Right, really important there from a visibility and a safety perspective. Doing it again, as I mentioned, continuous glass, using a combination where we needed additional stiffness, we would use additional core material, and you can see how it was essentially assembled in a number of pieces. On the right-hand side here, you can see some of the large Aero pieces, the belly pan. Here's an axle pan, and then obviously a very significant boat tail. That was, those parts were assembled and then shipped to Navistar for the vehicle buildup. And then on the trailer, right, this is a 53-foot trailer, so big part. And essentially we molded the floor in one piece and then the trailer box in one piece. And again, with our experience around building wind blades, they're now typically 70 meters. We would actually consider this to be not a large part, but something that we're extremely comfortable with. Being able to mold this was not again, for us, it's really not a challenge to be able to build these type of large products. So this gives you a sense of how we did it, right? Now I'm going to transition to what were the results. Obviously, I think that's really critical here in using technologies of, okay, we used composites, we had all these reasons why. What were we able to achieve, right? And so on the left-hand side of the screen, you see a plot. If you look between the green and the red, you'll see a significant difference. That's basically aero reduction that this particular truck was able to achieve. And as I mentioned, there was a lot of focus on the development of aero, right? And how aero can be improved. And if you look here, right, I'm going to key in on that fuel economy benefit, right, of almost 20%, right? Roughly 20% of what we were able to achieve was aero was a huge piece of this. So obviously all those parts that were designed and put on the truck make a big difference, right? When you see trucks on the road today versus this truck, the aero that this enables is very significant. And then the other piece here is that there's been a lot of focus on tractor aero, but I think one of the key things that Navistar wanted to showcase here was the combination of tractor plus trailer, what you could actually accomplish. And so here, basically, I'm going to round up about 40% of the aero improvement was due to the trailer. So overall, from a program standpoint, how did we do, right? And I think this here is right. The goal was 100% freight efficiency. We achieved 170%, or Navistar achieved. I'll go back to fuel economy. I just think it's easy to think from a fuel economy standpoint. It's a little bit easier to relate to. Typical truck on the road today is about 8 miles per gallon, right? This truck achieves in real world operation about 16 miles per gallon. So 2x what the trucks that you see on the road today. And overall, this is from program total mass was reduced by about 4,000 pounds. So a lot of mass was saved. As I said, that one of the reasons, but not the only reason to go to composites. And I think the really cool and rewarding piece here is that in talking with Navistar is really, they would state that composite structures were the primary enabler for Navistar to be able to meet the SuperTruck 2 program goals. So really cool when we step back on a program like this and see what were we able to achieve, right? And being a key part of that, I think is it makes all of us feel really really good and proud to be a part of the program. So just to wrap things up here, one, as I just mentioned, composites were a primary enabler for Navistar to meet their ST2 goals. OEMs are moving towards utilizing structural composites. And you're going to see this over the next few months. You're going to see a combination of delivery vehicles, heavy duty vehicles, of actually production solutions that will be announced, and also full cabs. So, I know this was a development program with Navistar, but I think the point I would tell you guys is there's more good stuff coming, and it truly is excited. And the last point here is, we're really excited to collaborate with the OEMs to develop innovative new products. So appreciate everyone's time this morning, and Dale, thanks for the opportunity to tell you guys about what we did here.
Yeah, thanks, Todd. That's really cool. I mean, it's great to see this kind of thing happening in over the road trucks. So there have been a handful of questions posted in the chat and one in the Q&A. And given time, we'll move on to Cindy. But if you'll go into the Q&A and answer that, Todd.
Sure.
The one question that's there, and then answer the ones in the chat. Make sure you you set your 2 on the chat to everyone, not just the host and panelist. That way it'll make sure it gets out there to everyone.
No problem, Dale.
Okay. Thanks again. Appreciate that. So Cindy, you are up to take us in the home stretch here. And,
all right.
All right. So you're good to go.
All right, great. I always worry because you never know how this all works out, but thank you all, and really appreciate both those presentations. Todd and Jeff, you did a great job on giving us some new innovations. So really, CAMX is about more innovations and an opportunity for folks to get together, but wanted to just give a little bit of some highlights so people know what's coming, and also just to keep in mind that it's coming up fast, October 30th, if you can believe it. So we're going to be spending Halloween in Atlanta. And I want to emphasize that it's not just an ACMA affair, SAMPI as well as our partnership that we have with all of you all here with IACMI. And so we're very pleased to be able to bring this to you, just to give you a little bit of the schedule that we have and some things I wanted to highlight for you. Do plan on coming on Monday. We do have quite a number of tutorials that have been set up. One in particular I wanted to highlight. They start at 9 a.m., go to 4 p.m. We've got 4 of them happening. One I wanted to emphasize, we're going to be doing the fundamentals of life cycle assessment and EPDs for manufacturers. So for those who are having to get into that space, we really wanted to break it down, take some time, do a bit of a deep dive. But the tutorials are quite good. We're going to have our awards, both SAMPI and ACMA as well. But then things really start right away as soon as we get into Halloween. And I'm excited about Joan Higginbotham, who's a former NASA astronaut and is now the director of open innovation at Collins Aerospace. She's going to really kick the whole thing off with a general session. We'll have our CAMX awards there as well. We're excited about that. And then we really get right into the exhibit hall and the conference programming. I'll talk a little bit more about the conference programming as well, but just want to emphasize that is really where CAMX shines, and some really great things. We are bringing back the poster sessions, so we're excited about that, and we've had a lot of success with the Young Professionals meetup. So if you have young professionals who are on this webinar, please make sure you attend that, and if you have some in your team that are going to be showing up, do make sure that they attend, because we really do want to make sure that everyone feels welcomed and they get the best out of it. And then just to, let me see if I move on to the next slide, give you a sense of what do we have happening at the exhibit hall. The exciting news is we really are going to be quite large this year. The theme that we are hearing is that exhibitors have significantly increased their footprints, so the booths are going to be larger, and we have more than we've ever had before. So excited to see that happen. We're going to have a number of presentations that are going to be happening in Park Place, some campfire presentations. Those will be in Tuesday and Wednesday. We will have 5 exhibitors that we know we're going to be doing live demonstrations. I think that's why we have this bigger footprint. And of course, the Composite one with Closed Mold Alliance is always leading the charge on that. One thing I did want to emphasize is due to our location, there are going to be a number of tours. Massivit, for example, on Monday we'll be doing AM and PM tours. So you will have an opportunity to go to some facilities. So do plan a little bit of time for that as well. Well, I told you that the big part of CAMEX is that we have these presentations. You know, this was really an intense year. We had the largest applicants ever. So we had 165 applications to present at CAMEX. We couldn't accept them all, so it's quite prestigious at this point to have been chosen. And so we're excited to see just the sheer number and volume. We've got a track for everyone. There'll be 9. Additive manufacturing, advances in materials, bonding and joining, you know, business, regulatory, and workforce development, design analysis simulation, green and sustainability, manufacturing and processing technologies, market applications, and non-destructive evaluation and testing. Those are just the tracks we have. I mentioned the campfire sessions before. We've got education sessions on the floor, some of which are free, and some of which are what you have to do to be included in the broader pass. I would encourage you to go to our registration site. We really have a program depending on how many sessions you're interested in for everyone. The other thing that this doesn't even really show on this is all the committee meetings. I know ACMA has quite a number, SAMPI has some, I know IACMI is doing some meetings, so there's a lot happening on the sides. So we anticipate it's going to be quite full. Our expectation is that we're going to have around 7,000. I wouldn't be surprised if we're on the upper end of this, based on just, you know, what's going on. And have some fun because, like I said, it is Halloween. I've already ordered my Halloween costume, so I hope that everyone takes advantage of that, as well as all the opportunities to network, which at the end of the day, that's really what CAMEX is about. The one thing we wanted to make sure everyone knew is that this is a new convention center for us. And for those who haven't been to the Atlanta Convention Center, the hotels aren't as quick and walkable as others are. So we will have shuttle service for everyone. So when you're booking your hotel, just take a look at that so you understand and plan a little bit for that. It's not bad, but it's just something you want to keep in mind. And there's quite a lot that you can do, but I did want to emphasize just to make sure that you got the best rates, to make sure you're booking by October 11th. There is another event on the other half of the convention center, so we're not the only show in town. So I would definitely not wait to book your hotel. It will fill up, and so we're already noticing. Here's a little video. All right, well, that's all I've got, and open to questions or whatever else you'd like to do, Dale.
Yeah, I was looking through your slides and in the video, and I said, wow, there's a whole bunch of people I know in those videos. So it's gonna be good to go see all those folks that I do know. Great thing there. You mentioned something about packages. You know, are there going to be things like show samplers and you've got those again, where if you want to go to 3 or 4 sessions, you know, you can pay for just those and not have to buy the whole programming.
And we even have student packages as well. So yeah, and if you're just looking to go walk the floor, you can do that as well. And so in fact, when I was looking at it, I was kind of surprised. I think we have about, it almost seemed like 6 different packages depending on what works for you.
Okay. And then of course, I think, what everybody gets to see on the floor as well are things like the CAMEX awards and, the combined strength awards and things and so forth that happen as well.
Yes. Yeah. And it's exciting because there'll be an opportunity for the those who've won the awards to have all those are out all the time, so you can go check it out. But there will be presentations by the award winner, so you can get a sense of what's happening there. I would encourage you to download the CAMEX app because that'll make it possible for you to build essentially kind of your itinerary. It'll give you directions around the floor so you can find everyone, and just makes it really easy to be able to navigate.
Sure. Yeah. No, looking very, very promising. Okay. And Kim has put into the chat a link to be able to go, get a booth or to register. So, but it is the camex.org. And, looking forward to that. Okay.
And then, the one thing I'll be remiss if I don't call out, I really, I told you about how CAMEX is just renowned for the educational programming and these technical sessions. We had Rosario Figueroa and Martha Lowe really lead a team, and we had 40 plus volunteers on the oversight team that really chose all of those papers and put all the work into this. It's a tremendous amount of work. It's amazing to me, 120 sessions. It just blows your mind when you think about just the sheer amount of material there. But I just want to thank those folks in particular and our volunteers for doing all the work of reviewing all these submissions, because like I said, 165 applications, it took a little time to get through them all. So
yeah. Okay. I appreciate that. Thank you, Cindy. We've got a few minutes left, and I'm going to use this time. I think I'm going to go back to Todd and let him verbally answer a few things, because we are recording this and we'll capture those answers. So Todd, I don't know if you answered the question in the chat or in the Q&A. Did Navistar consider any recycled composites in your design? And
yeah, Dale, it's a good question, and I think the short answer is anywhere we could consider using recyclable materials that we thought would make sense, that would help the program goals, we would. As I listed, the primary goals of the program were not associated with recyclability, right? So,
okay.
So the short answer is if we could select materials that helped us achieve the program goals, right? Which again was commercial viability and freight efficiency, right? The challenge we have oftentimes with recyclable materials, and we want to move towards recyclable materials. The challenge we have is there's typically there's trade-offs with that, right? Those trade-offs are cost or typically lower performance. Right now, if that's not the case, then obviously we would use those materials.
Okay. So how much of the improvements are attributed to the Aero design and how much to the weight savings?
I don't have the specific breakout of that in front of me. Some of the information is published. Some of it is, I'll call it as Navistar confidential, right? Sure. Obviously, as a DOE program, Dale, as you're aware, a lot of it or significant amount of it is made public. I'll have to go back and see if that breakout is available publicly. I don't have it off the top of my head.
Yeah, one thing, and I think a couple questions, this may answer a couple questions, is you showed improvement from 8 to 16 miles per gallon, but obviously when you talk about ton miles per gallon, so you take that weight out, then that means you can, in a place where you cap out on tonnage, it allows you to add more tons to the
exactly
and still stay under the 80,000 pound.
100%, and the comment around is right. These new, whether it's hydrogen fuel cell or electric, right? You're adding a lot of mass to the vehicles. So you obviously, and that's why they look at freight efficiency versus miles per gallon, right? Sure. Because freight efficiency takes into account now I can carry more cargo, right? And now if let's just use for this example, I've got 4,000 pounds now. That mass was saved. The statement would be made is now I've got 4,000 pounds more cargo capacity.
Okay. Do you have, and this is probably out there somewhere, I would guess, on the DOE website, but, what was the total value of the project in terms of total R&D dollars? Do you remember?
Well, again, it's across all programs. I want to say it's close to because I think there's 4 programs, and they added an additional, I want to say close to $200 million.
Okay.
It's somewhere in that neighborhood. My number could be off, but somewhere in that. And it's basically between industry and government. It's I believe it's 50-50 on
Okay.
that in terms of
Yeah.
what that split is. But I would use a round number of about 200.
Right. And then obviously all wasn't just structure. I mean, there was
No,
engine
100%.
efficiencies and other things too. Yeah.
No, but I think going back to the comment, and that was a Navistar comment of, obviously, right, in terms of them of, achieving better thermal efficiency, all that, we had nothing to do with that. But in terms of achieving the program goals, Navistar, has made the statement that we were, a key contributor of all the work that we had done or did to make that happen.
Okay. And then I have one last question, and we'll turn everybody loose. Did you calculate a cost penalty per pound saved, or that is shareable, or was there a target for value of weight savings?
Well, the short answer on this was no. I will say on other production programs, I can give you a range that I typically see in the industry in commercial vehicles, and that's anywhere from probably $1.50 to upwards of $8, right? All depends on what you're hauling, right? So, right, if you're bulk hauling, right, that number gets as high as $6, $7, $8 a pound, right? Because of obviously the value of being able to haul more. If you're hauling packages, that you cube out versus tearing out, then the value is obviously less. So it really depends upon the application.
Okay. But, nobody's ever going to turn down fuel economy.
No.
Okay.
No, but I think overall, I mean, to me, it's just pretty amazing to think about. These trucks have twice the efficiency, more than twice the efficiency than the trucks that are on the road. So pretty cool.
Great. All right. So once again, I want to thank all 3 of our panelists today, Jeff, Todd, Cindy. Looking forward to seeing all of you in Atlanta next month, at the end of next month. And I guess I got to go shopping for my Halloween costume.
Can't wait to see it.
Thanks, everyone.
Thanks, everybody.
All right. Thanks
Take care.
all.
All right, bye.
Have a great week.
Bye-bye.